Now, equation of plane defined by two intersecting lines. Two intersecting lines in the space form a plane. We see in this figure two intersecting lines D and D prime at I. Then these two intersecting lines form a plane P. We need to find a normal vector of a plane P. As we know that a normal vector of a plane P is the cross product between two non-collinear vectors on the plane P. So we can get the normal as VD cross VD prime. So to find the Cartesian equation of the plane P, know that every plane defined by a point and a normal. A point on the plane P is I, and the normal of the plane P is VD cross VD prime. So to find the equation of P, we need to take a variable point M, X, Y, Z on P. By example, M here. So I, M, and N are perpendicular. By solving I, M dot N equal to 0, we get the equation of the plane P. Now let's go to an example about this. Consider the two straight lines D of parametric equation x equal m, y equal m minus 2, and z equal 2m plus 1, and D prime of parametric equation x equal t plus 1, y equal 2t, and z equal t plus 2, where m and t are real numbers. The first question is to show that D and D prime are intersecting at a point A to be determined. And the second question is to find the equation of plane P defined by D and D prime. First question, we need to find the coordinates of A intersection of D and D prime. We need to solve a system of equation x equal x and y equal y. Then m equal to 0 and t equal minus 1. The answer of variable in this system. Substitute in that the values of m and t and check the result. Replace m by 0 here, we get z equal 2, and replace t by minus 1 here, we get 1. So same result. Then D and D prime are intersecting at a point A, and by replace m by 0 or t by minus 1, we get the point A. So m by 0, we get x equals 0, y equal minus 2, z equal 1. Therefore the point A is 0, minus 2, and 1. Two intersecting lines in the space form a plane. To find the Cartesian equation of this plane, we need to find at first time a normal of this plane. We know that the normal of the plane is the cross product of two non-collinear vectors on this plane. So we can get the a director vector of D and a director vector of D prime. VD it's 1, 1, 2. VD prime it's 1, 2, 1. Then the normal of P is VD cross VD prime. We get normal equal to minus 3i plus j plus k. Now let m, x, y, z be a point on P. So am dot n equal to 0, since n the normal and a and m 2 points on the plane, so n perpendicular to am. Therefore am dot n equal to 0. By solving this equation, x prime plus y prime plus z prime equal to 0, we get the equation of the plane P. Now equation of a plane defined by two parallel lines. Every two parallel lines in the space form a plane. We need to find a normal vector of this plane. Then we can take a fixed point A on the line D and a fixed point B on the line D prime. And we know that the normal vector of plane P is the cross product of two non-collinear vectors in the plane P. Then we can take the two vectors A, B and VD, the direction vector of D, and the cross product of these two vectors give a normal of the plane P. And finally, to find the Cartesian equation, we know that we take a variable point mx, y, z on the plane P, then a, m, and n are perpendicular. So by solving the scale product am dot n equal to 0, we get the equation of plane P. Now let's go to an application about this. We take two straight lines D and D prime. The question is to show that D and D prime form a plane with the equation to be determined. V of D it's 1, 2 minus 1. V of D prime it's 2, 4 minus 2. V of D prime it's the double of V of D. Then the two straight lines are parallel or confounded. If they are parallel, then they form a plane. We need to show them not confounded. So we can take a fixed point on A by m equals 0 and prove that this point A not belong to D prime. And we show that two straight lines are just parallel. Two straight lines parallel form a plane. We need to find a normal vector of this plane. We can take a fixed point on D and a fixed point on D prime. For m equal to 0 we take A, and for t equal to 0 we take B. The normal vector n is AB cross V of D prime, a direction vector of D prime. 2, 4 minus 2, it's V of D prime, and AB, XB minus XA, YB minus YA, ZB minus ZA, we get AB. So a normal vector, it's AB cross VD prime. It's minus 10 plus 18 plus 26. Let m, x, y, z now be a point on P. So am dot n equal to 0. By solving this equation, x prime plus y prime plus z prime, by replace am and the normal by their coordinates, we get the equation of the plane P. So